This month's SBE Webxtra is brought to you by Wheatstone, maker of the intelligent IP audio network used by studios around the globe. The AES-67 compatible WheatNet IP intelligent network is the most comprehensive end-to-end studio network system in the world, with a full line of consoles, software apps, IP audio appliances, and third-party add-ons for any studio workflow, size, or purpose. Wheatstone. Well, good afternoon. I'm Chris Scherer, Member Communications Director of the Society of Broadcast Engineers, and the co-host of this month's episode of the SBE Webxtra, the SBE chapter of the web. This is a monthly SBE meeting usually held on the third Monday of the month. The SBE is the Association for Broadcast and Multimedia Technology Professionals, with about 5,000 members, mostly in the U.S., but also around the world. The host of today's SBE Webxtra is SBE board member Kirk Harnack, who is also the chair of the SBE Social Networking Committee. Hello, Kirk.
Hey, Chris, and good afternoon to everyone, and to you, Chris. I appreciate the intro. And today, on today's program, today's SBE meeting here on the web, we've got a very interesting couple, and I have just been delighted to get to know these two professionals. And when I go to look at their resume, curriculum vitae, oh my goodness, I had no idea that each of these guests coming up, Garrison Cavell and Cindy Hutter Cavell, were so accomplished. I mean, my goodness. So we've heard of their firm, Cavell, Mertz Associates, for some years, and all the really good things that they do for the industry. They will be our guests, talking about a wide range of issues of interest to any engineer, radio or television, multimedia. We're going to be talking to them for the next few minutes. But first, Chris, I believe you've got some announcements and things of interest from the Society of Broadcast Engineers.
Sure do. Here is your SBE member update for October 21, 2019. The SBE held its national meeting last week in Madison, Wisconsin. Wayne Pacina was sworn in as the new president of the SBE, as were the other officers and 6 directors. Officers serve 1-year terms and directors serve 2-year terms. There are 6 other directors who are now halfway through their terms. The SBE National Meeting was held in conjunction with the Broadcasters Clinic, a presentation of the Wisconsin Broadcasters Association and the SBE chapters of Wisconsin. The board conducted lots of business for the society, and some of the notable items that were covered and approved include a new SBE chapter being authorized. We welcome SBE Chapter 106 Panhandle. This chapter serves the Florida Panhandle and southern Alabama and Mississippi areas. Mark Johnson is the chapter chair. An expansion to the SBE Member Plus program was approved for SBE Life and student members. They will be called the SBE Life Member Plus and SBE Student Member Plus. Both will be available beginning January 1, 2020. The SBE board approved the 2020 budget, and SBE members will likely be pleased to know that there is no change in member dues for the coming year. And after the strategic planning conference held in June 2018, one task group looked into a redesign and update of the SBE website. That's also been approved, so look for that in the coming months. The 2020 SBE National Meeting will be held in Syracuse, New York, in conjunction with the Central New York SBE Chapter 22 Broadcast and Technology Expo. And by the way, the SBE membership meeting was streamed live. We are getting the recording of that together, and that will be posted on the SBE's YouTube channel within a couple of days. Looking at some webinars by SBE, there are a few coming up you should take note of. One is 2 days from now, October 23rd. RF201 Module 8 AM Multiplexed Antenna Systems. Tom King, President and CEO of Kintronic Labs, presents this AM multiplexing webinar that covers the feasibility criteria for multiplexing 2 or more AM stations. Basic isolation filter designs and tower feed methods for improved audio bandwidth of multiplexed AM stations will also be covered. On Thursday, November 14, we have Implementing SNMP Part 2. The Part 2 of this series will build on the SNMP fundamentals presented in Part 1 by looking at the implementation of an SNMP platform to provide a robust monitoring and notification alerting environment from IT equipment to the transmitter. And on December 12, we have Workbench Tips. The author of Radio World's popular column and Telos Alliance Western Regional Radio Sales Manager, John Bissett, will bring a combination of tips from his column and discuss the conversion to AOIP and what AES-67 means to you. This will be a free webinar and an easy way to earn recertification points thanks to the TELUS Alliance for sponsoring the webinar. For information on all the webinars by SBE, go to sbe.org/webinars. On the certification side, if you'd like to take an SBE certification exam, here are some dates to know. Local exams will next be held at chapters the week of February 2020, February 7th, 2020. The application deadline is December 31, 2019. And SBE certification exams will again be held at the NAB show in Las Vegas, this time April 21st, 2020. The application deadline for that is March 9, 2020. Don't usually give the years, but since it's up on the calendar, we may as well make sure we got all our ducks in a row. If a local chapter exam is not convenient for you, private proctoring is available. Contact the SBE National Office for details. And for more information on SBE certification, go to sbe.org/certification. And that's your SBE member update for October 21, 2019.
You know, Chris, I've always gone for the private proctoring. It's kind of that white glove service, you know, it makes you feel special.
Well, when I was the certification chair of my chapter here in Kansas City a few years ago, I offered that all the time. Not that, I mean, there are 5 or 6 local exam opportunities at chapters throughout the year, but for some people, it just never seemed to would fall into the right place. So I would always extend the offer to offer private proctoring to them so they could pretty much take an exam almost anytime they wanted to. We just worked it out on our own schedules instead of fitting it into the official time window. So whatever works, it's all about trying to make it easier to get SBE certified.
Indeed. I appreciate you doing that. And our chapter in Nashville, chapter 103, does that as well. We try to fit it in, but if somebody needs some special attention, then our certification chair will just make those arrangements, and it works out just great. So highly encourage that. By the way, I signed up for this Wednesday's webinar with Tom King, and I encourage others to do that too, about multiplexing AM stations together. Chris, thank you so much for all that update. I appreciate it.
Certainly.
All right, let's bring on our guests, and I think we should just do ladies first. Cindy Hutter Cavell is here, along with her husband, Gary Cavell. Cindy joined Cavell, Mertz Associates full-time back in 2010, specializes in television facility technical design, systems and workflow, personnel evaluation, and fixed microwave systems, and she has done so much more than that. Garrison is here as well. He's worked in management and technology positions in communications and broadcast systems for over 40 years. He was a co-founder of Cavell Mertz and its predecessor in firms back in 1989. Lots and lots on each of their lists of things they've done. So welcome in, Gary and Cindy. How are you?
Good, Kirk. Thanks a lot.
That's all lies, by the way. None of a bit of it.
Well, they're certainly believable. They're true lies. True lies.
That's right.
Glad to have you here. And we've run into each other at a few of these various radio and combined radio TV functions. And we asked you to come on the show because you two are so busy, and you have plenty of professional clients, but you're out there getting your hands dirty, doing the work out there, plus doing plenty of paperwork, helping stations to maximize and serve the public as best they possibly can. And that's what consulting engineers do to a large extent. But you had some topics that you wanted to cover, things that you don't get out to SBE meetings to cover. So we figured, hey, let's make this available to all SBE members through the SBE WEBxtra program. So Garrison, we had a short list of things that we might want to talk about today. And one of those is just the first topic, that technology, well, it's changing as it so often does, but we all need to work at keeping up. Tell me what you're referring to.
I guess that's when I first got into this business, it was AM radio. That was king. FM was something that people were maybe not so interested in, or they turn in their FM licenses. And it seems like you turn around and things have changed. And I remember, I'm old enough to remember black and white television. Yes, I'm that ancient. And then when color first came out, how astonishing it was. And then digital television, everything keeps moving forward faster and faster. And you can't stay complacent. You can't stay doing what you're always doing. And as a technologist, as an engineer, as somebody in the broadcasting profession, you've got to keep learning. So that's why Cindy and I and others in the firm like to go out and give presentations and help the younger people and some of the older guys come along, learn, embrace the industry, and see there's more opportunities coming out every day. There was no such thing as cloud when we were lucky to get audio to pass through these cloth-covered wires, and now it's so many things you can do just in a computer, which were unheard of. So keeping up is very, very hard. I'm an old Luddite, and I go into a transmitter plant now, and I'm happy when I see the RF stuff. But then you can't hook an audio wire to the transmitter. You need to have some kind of RJ, whatever the heck that is, hooked up to it.
RJ45, yeah.
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 I mean, that's one of those things where I need to learn that. And that's why SBE is important. You guys go really above and beyond Call of Duty to help educate people. And that's outstanding.
It seems like, oh, I'm sorry. Go ahead, Cindy. Go ahead.
Well, as professionals as well, we have to keep up with what's going on because our clients are going to ask us. And we have to make sure that we can operate the latest gear and understand the latest technologies and understand the latest SMPTE models and everything else. And we can't just sit and say, well, I remember AM radio.
Nope, doesn't work. It's fun to reminisce, but it doesn't get you anywhere. We're beyond AM radio. We're doing more exciting things. And I think the future will change in how we consume entertainment, information, sports, all the sort of stuff. It's in front of us now. If you go to the NAB show or any of the other conventions, you'll see connected cars, and the dashboards aren't the same as they were back in the ancient times.
We're going to move up to really current issues, but you have to, if you drew a line in the sand somewhere, it seems to me that a lot of the changes we experience today with television repack, how that affects FM stations, how C-band is a bit up in the air and question. We might get some of that taken away as broadcasters. To me, a lot of this started back with the television broadcast auxiliary services, BAS changes that happened some years ago. And Cindy, I understand you were a big part of making that happen and making sure broadcasters were taken care of and compensated contractually. Can you give us a little thumbnail sketch of how BAS got approached and what you did for it? And then maybe we can look at that as a model for how we've gone forward with changes that are even occurring now and have occurred in the previous repack. Cindy?
Sure. But I'd have to disagree with you for a second, Kirk, because I think that a lot of this technology push started right after the turn of the millennium when things like handheld mobile devices started coming out. I mean, if you think about 2000, 2001, 2002, I was just starting to get not even a smartphone, but just a flip phone that I could use. I mean, kids that our kids were born in 1993 and they don't remember what it's like to not have a mobile phone. So building on that, Sprint was looking for some additional spectrum, partly because they sat kind of checkerboarded in the middle of the 800 megahertz band, which was interfering with normal two-way communications and first responder communications. And the FCC said to Sprint, look, you guys have to do something to unwind yourselves out of this spectrum to keep yourselves away from the first responders because you're really causing problems.
Yeah, the original Nextel system was really, there was some at 2 gig maybe, and some at 800. They were all over the place, different parts of the spectrum, and that they were right up against the public safety stuff. It was a serious and big problem.
And so Sprint came up with a fix for it, and they basically said, okay, FCC, here's what we're going to do. We're going to consolidate ourselves at one end of the 800 megahertz band, and we're going to consolidate everybody else at the other end. But it means that we Sprint lose about 15 megahertz of our original 800 megahertz spectrum. And here's what we have in mind. We're going to carve out a little section of what used to be the 2 gigahertz microwave band down at the very bottom end. And we're going to give a little bit of it to the satellite phone guys. And we're going to keep a little bit of it so that we have a nationwide 2 gig license. So the FCC said, yeah, that's fine. But you guys, since you're the new guy into the marketplace, you have to make sure that everybody is taken care of. So instead of doing a spectrum auction, Sprint just said, okay, we're taking 25 megahertz of this spectrum. We're going to repurpose it, and we are going to squish the rest of the 2 gig microwave band up 25 megahertz and give everybody brand new digital radios, because this was also on the cusp of OFDM for microwave and digital microwave. And so it was a whole lot easier to get more data in a smaller space. We were going from 12 megahertz channels to 8 megahertz channels, or 6 megahertz channels in some places. And so it was a whole lot easier using the digital microwave to be able to do this.
But that's when folks had to learn how to use digital techniques. I mean, we're all used to turning up the radios very, very hot so we can get through all the clutter. And you find out in the field, no, turn it down. And you get in arguments with major chief engineers like, no, you got to turn it down, dummy.
Well, no, I mean, it's true. It
she used stronger language than that.
It caused a learning curve for operators and for people, because when you do analog microwave, you're laughing, but it's true. Analog microwave, more is better. Just blast the electrons off that receive dish, no problem. But when you're doing digital, there's a certain amount where a lot is good, but if you go one step more and do more, it's not better anymore. And guys would call me up and they go, I got tons of signal on the receive end, but I just see black. What's wrong? My stuff doesn't work. You guys have to give us new stuff. And I'm going, no, just back the transmit power down just a little bit. You got to be kidding me. I'm not seeing anything. I need to make it go more. No, you don't need to. And because digital microwave has that threshold.
And that's when we started to learn about digital.
And they had never seen, again, this was for microwave technicians, chief engineers, if they got into DTV early on. And again, this was before the DTV transition as well, because this was happening in 2005, 2006, weren't used to seeing digital waveforms. They're used to seeing something that looked like a Christmas tree, not something that looked like, I think somebody once referred to it as a Bart Simpson head. flat on top.
Yeah. I couldn't swing the dishes around as quickly. You had to be careful about that. It's a different technology.
Yeah, we as engineers, we know about this digital cliff, and full quieting may not be something that you really want to have. I want to ask you about that, but Gary, you provided us with a few pictures, and we need to, as the hour goes on, look at a few of these. And I'm really intrigued by your first one, where you've got some engineering quotes on there. If we can get our producer Suncast to pop that up on the screen, this some great quotes here. Gary, you want to talk about these?
Sure. Well, I read voraciously because as the papa of the firm, whatever you want to call me, I feel like I need to know what other people are thinking, and not just in broadcasting, in all disciplines, because it's getting to be more and more one world. And I like this thing that Robert Luckey said in IEEE Spectrum: all engineering knowledge has an expiration date. The trick is to know when. That's pretty cool, because my AM knowledge is still valuable, but it's not as relevant. The people who are going, I remember I had an FM 1C exciter, my first FM job, and I thought, great idea. I think I'll go ahead and replace all the tubes. Bad idea. And technology moves on. We don't use vacuum tubes anymore. We don't use a lot of things. It's when is it no longer valid? When is it time to change it to all digital, like David Colazar did here in Washington with all digital AM? And I liked his other quote in the Atlantic, that the technology moves faster than our imagination can keep up with. And it seems to be going, to me, it may be because I'm an old dude, but it seems to be moving faster and faster and faster.
Well, now I was going to disagree with that until I read the next line, because that makes the first line make sense, in my opinion.
You build on it. You build on it. Yeah. And it's just an amazing. And if you start thinking about it, yeah, we developed something that gives you another something, gives you another something. And where was the first thing? It fell off the table. So it's exciting and it's frightening, particularly and I talked about this, I guess, at the tech conference at the radio show, where some of the older guys are getting afraid and they're intimidated by this stuff and they don't want to talk with or help the younger people who need to learn what we know. We all really need to work together in teaching each other our craft. The old craft still is valid. The new stuff, the digital stuff, the IP networking stuff is horribly frightening to maybe some of the older engineers. We all need to help each other learn this stuff.
The whole topic of how test equipment is different now than it used to be. I used to carry an oscilloscope and a Simpson meter, and I think I may have had an inexpensive Fluke voltmeter when I was a contract engineer back in the 90s, 80s, and 90s. Yeah. Like I said, it was for the cheaper models. And of course, now you can get a volt ohm meter, a Chinese one from off the internet for $3. And we have a $3 one at each of my transmitter sites. But it seems like sometimes people in your craft, and maybe some people out in the field too, who aren't necessarily consulting engineers, it seems like some test equipment is a lot more affordable today. Back in the early 90s, I paid $8,000 out of my pocket for a spectrum analyzer from Tektronix, and it was a demo model. I got it way at a discount. And just about 5 years ago, I tried to get it repaired again, and they said, no, this is not repairable. Sorry. And they never even shipped it back. So how does test equipment these days look different? And maybe we can go into a bit of what could a broadcast engineer expect to have, and what should he really not expect to be bothered with, but to bring a consultant in? Oh, and I've got a follow-up question too. You may be able to afford now a lot more test gear than you understand how to use. And I feel that may be true with this crop of vector network analyzers that are available now. You can get them just a very few $1,000s. They're kind of affordable, but I'm not sure I would know what to do with the reading. So why don't you guys talk about test equipment these days?
Oh, sure. Well, remember, it cost a tremendous amount of money to buy the older test equipment, I guess because a lot of it was built by hand, or the industrial processes weren't as sophisticated.
And there were fewer of them being made.
Yeah, there weren't as many being made, and most of them were 85 pounds. I remember carrying my portable scope, which was, I believe, a Tektronix 535, which is a 1.5 feet wide and 3 or 4 feet deep, and down the levee. And I just realized, wait a minute, the Newton's law is going to work here. And I ran down the levee and up the stairs and blam, right into the door of a transmitter building with this thing on my shoulder like an idiot. So I didn't say it was bright. I just said I was determined. And that was a heavy thing to cart around. And I had my trusty Simpson 260, which was battered to hell. And then I needed something. Marty, God help us, came out with a remote control. And it had some kind of fancy stuff inside of it that a Simpson 260 made act funny. So you had to get something with an FET input. Radio Shack saved me for not a lot of money, but you couldn't buy a Simpson 260 for what the Radio Shack thing did. And you can wrinkle your nose at Radio Shack, but it saved my bacon to make sure that old remote control would work. And you look at, you mentioned measuring impedances with network analyzers. They're a powerful tool, and you're right, any one of these tools, spectrum analyzers, anything newer, even some of the older ones, you can get yourself into looking at the wrong thing. And that's just bitter experience and friendship of the other engineers in the market and consulting engineers. You try to learn from your mistakes and share with the other guy. Again, SBE seminars are great for that sort of thing, where you have Tom and the others coming on board saying, look at this is how we use it. The network analyzer, I can look at how long a transmission line is, FM or TV or AM. Does it have a ZID in it? Did somebody run a truck over it and I didn't catch that? You can use when I'm tuning up an AM array, I use the sample lines as extension cords to see what's going on at the base of the towers. You can just go ahead and calibrate out the sample lines rather than all this thing all over the place, stomping through the mud. It's amazing what a little experience will get you with the newer gear. And the same with network analyzers. You can, with spectrum analyzers, you can see a lot of things and imagine the worst, and where all you've done is maybe overloaded the receiver portion, or you've got You don't put a pad in. There's an ancient spectrum analyzer on the left and the Rodian Swartz in the middle, which we paid too much money for. And that little tiny thing down in the lower right there, that is a Tektronix spectrum analyzer. And I think we paid, what, $2,500 maybe?
Right.
And that doesn't go DC to daylight. It goes maybe to 3 or 6 gigahertz. But you hook that up to a laptop. And that's where the big change is you have these modules now that you plug into a laptop. So have laptop will fix. And you have VNAs and spectrum analyzers and all sorts of sophisticated tools with the help of your laptop. It's amazing.
I noticed that you mentioned that one from Tektronix, and our SBE chapter recently had a demonstration by the folks that I think at Copper Mountain Technologies.
Yes,
because they had some VNAs that were about the price range you mentioned, and I don't know if they're useful for anything except maybe your CB antenna,
Absolutely.
but you can get a VNA on. No, I didn't mean those you just mentioned. But I was foreshadowing. You can buy a VNA online for like $60 as a kit module. It's not calibrated. It wouldn't be useful, I think, for actual real heavy duty work. But if you want to play with one and see what a VNA will do, you could do this for under $100 from some of these Chinese websites.
Well, the interesting thing, I mean, you talk about the Copper Mountain, and we have an enormous 4-input VNA that's made by Hewlett Packard that was probably $70,000 when it was bought new. And
Ouch.
It weighs 65 pounds. And, I kind of drag it along behind me like a recalcitrant puppy when I have to use it. But the brilliant thing about it is that it is 4 inputs. So if Gary's got to measure 4 AM towers all at the same time using the transmission line or the sample lines as extension cords, he can do all 4 at once.
There's all sorts of tools that you can use now.
But the Copper Mountain is good for only 2 inputs.
Yeah, or you can use it, the 1-input Copper Mountain. There's some of the ham magazines have vector network analyzers. So lots of different ways of using them, and a clever engineer can take a loop and amplifier in, so you can overcome noise at a site. Again, FM, television, AM, and you don't need to have this big, heavy tool anymore. And you're worried about calibration. Network analyzers self-calibrate. You can go ahead and adjust them and normalize where they're at for this task at hand. And particularly at AM, 5 ohms is probably close enough for a lot of people, and I've seen things a lot worse than that worked and were on the air and had good fidelity.
Although I have to tell you that there's one trick that our big old HP VNA does that the Copper Mountain will never do, and that's use the display upside down. Yeah.
If you have, when you take these things around the country a lot, they start to get funky, and if one pin goes wrong on the HP, you'll get a mirror image. And that's really exciting when you're at 3 o'clock in the morning, you're tired and you're cranky, and this thing is now backwards, upside down, and ugly. So, but there's a port on the back where you hook a computer monitor to, and you're back in business. But yeah, there's the magic and romance of radio.
In addition to these fancy pieces of test gear, there's also the notion of field strength measurements, and you've got some ideas on that, and you've got some pictures here that I'd like to understand what some of these pictures are that you're showing here. And by the way, we're going to get into the whole topic of aerial, that is drone measurements, in the second half of our meeting today. What are we looking at here?
Well, in the ancient days, this was, I guess, from a proof of performance for WJZ TV in Detroit back in 1950, when television was first born and widely distributed. That's an old woody station wagon with a little mast in the back and a dipole antenna, and there's a federal field strength meter inside that literally was 100 pounds. And they said you take 2 men and a boy to carry. It was tube type operated, and you had a multi-vibrator supply, and it just was an ugly way of taking field strength measurements. And then you came along, among others, Potomac Instruments. That's the unit below the station wagon there, where it ran on batteries, and it wasn't that heavy. It was maybe only 15 pounds. That was pretty cool. You could lug that around. And oh, by the way, the FCC for FM and television requires you to measure signal strength 30 feet in the air because that's where the graphs were originally made to predict coverage.
Because that's where people's home antennas were, on top of their houses.
Exactly. In the ancient days, you had aerials, not antennas, and they were outside, and they were usually about 30 feet in the air. So all the measurements done in the 30s and 40s and early 50s were to duplicate what people had at their homes, which was masts outside their homes. Right. So everything there is based on something nobody uses anymore. So that's why you see the truck that we borrowed with a nice little antenna kind of inelegantly attached to the top, and it runs down to a field strength meter, and we record what we see as we drive along. And please remember to lower the mast as you come near the power line of the bridge. And yes, we have stories about that.
Wow. And then we have the helicopter. I've heard about that, never done it myself. Talk to me about taking measurements from a helicopter.
There are a lot of folks that use both fixed wing aircraft and helicopters. And the helicopters is an easier tool because it's more maneuverable. And you hang an antenna out the window and describe a circle around the transmitting antenna to see if you can replicate the pattern that the manufacturer has given you.
To keep it kosher, you really should have the antenna fixed to a mounting pole and that's been FAA blessed in a local district office and all that fancy stuff, as opposed to hanging out the window, because you want to get the helicopter out of the picture of the measurement device. So sometimes there's a bit of a delay, but helicopters are a big price point. You know, it's like a Greek wedding. It's going to cost a lot of money to use one of those things. And also you can get into trouble with ground reflections, some of the distances and some of the areas you go into. So you have to see, is that reflection? It's like a multipath effect. If the wave is reflecting off the ground or something else coming to your antenna, am I really measuring, again, we have these great instruments, but am I really measuring what's going on, or a reflection, or is this thing getting overloaded? So it takes a bit of judgment and experience getting bitten and making a fool out of yourself repeatedly till you learn.
And there's a calculation that you can do to tell you exactly how far away from the tower you should be flying. But that's not always practical because you could be flying over houses or
government installations where they're unfriendly, or
anything else. And so there's a safety issue.
But helicopters are used a lot. The big reason why you don't want to use them is hassle factor, and the expense is fairly huge.
It's about $500 an hour to use a helicopter for measurements.
It sounds like a bargain to me, actually. Wow. Hey, when we come back, we're talking, by the way, to Gary Cavell and Cindy Hutter Cavell of Cavell, Mertz Associates. You are listening or watching to the SBE WEBxtra. It's our monthly SBE meeting on the web, bringing you ideas and people that probably we couldn't get to individual SBE meetings. And so that's why we bring it to you. I'm Kirk Harnack, along with Chris Scherer. Chris is here. He's the communications director for the SBE, and he is in his office. Chris, let's toss it back to you and continue on our show in just a minute.
Sure. Well, the SBE WEBxtra is made possible by the generous support of our sponsor, Wheatstone, and the SBE WEBxtra will be right back.
Hello, I'm Jay Tyler of the Wheatstone Corporation, and today we're going to talk about expanding your AOIP system outside your current manufacturer. If you're an existing AOIP customer and you want to take advantage of some other features or applications by a third-party manufacturer, you most likely are going to use an AES67 interface. To do this, you're probably going to need a master clock to keep the entire facility synced together. After that, you're going to want to pick the devices that will currently operate within your multicast range for AES67. If you're not sure of that, please contact your manufacturer to make sure they're going to be compatible. After that, you're going to want to make a detailed list of all your multicast addresses to and from the system. That will eliminate any overlapping that could take place. So for more information about this, please get in touch with your AOIP provider and make sure that you can implement AES67 successfully into your existing system. This is Jay Tyler of the Wheatstone. Until next time.
And we thank Wheatstone for sponsoring the SBE WEBxtra. By the way, did you know that by watching this webcast, you earned 1/2 of an SBE recertification point when you recertify? Keep that in mind when recertification time comes around for you. Let's get back to SBE board member Kirk Harnack and Cindy and Gary Cavell.
Thank you very much, Chris Scherer. Appreciate that. I appreciate the hand back off. And now I'm ready. You see, this is why I didn't have a great career as a disc jockey. Just kept the mic muted too often. Got into engineering when I didn't have to talk quite as much. We are talking with Cindy and Gary Cavell, and we were talking about aerial measurements at first via helicopters, and we've heard of this going on. I got to agree, it's got to be very expensive. But Cindy mentioned something pretty interesting, and I'd like to understand more about this because we're going to move into the topic of taking measurements with drones, and then, by the way, later in the show, later in our talk, we're going to have some measurements that, hey, ordinary non-Superman, Superwoman engineers like you and me can do ourselves. And Gary might give us some hints on some infrared photography. But for now, this idea of taking aerial measurements and multipath. And when you think about it, I hadn't thought about it before, but when Gary and Cindy have brought this up to me before, you kind of have to think about the ground, the earth, as this big, very imperfect, fuzzy mirror. And if you're taking measurements up in the sky, you've got a direct path from the antenna, from the transmitting antenna to the receiving antenna, and you've got this bounce path. Now, we all know about multipath at FM and TV and UHF frequencies. We understand how that can work, but we often don't really think about the ground itself as being a good source of multipath. So, Cindy, you mentioned some calculations, and if you would tell us a bit more about calculating the distance from the measured antenna, that would be pretty interesting.
You got a couple things going on that we just threw up a spreadsheet, which we forgot to share with you, but there's something called a Fraunhofer formula. And there's also, I think one of the slides will show you, you have to, whenever we go on a mobile shoot for a drone, and you should do this for a helicopter, you've got to look at the reflection angles. Where is the drone or the helicopter going to be? And where is a reflection point on the ground? And you actually can draw a little 3D map or use Google Earth. And is it a wheat field? Is it a wheat stone field? Sorry. Is it a lot of rocks? Is it going to be a lake, which is perfectly reflective?
Is it a parking lot?
Is it a parking lot? And what frequency you're dealing with? So you have to think about, gee, am I likely to see a reflection, or is there something going to be in a way that'll save it? And one of the techniques might be you do the measurement first in one direction, and then you go back the other way and see if the problem moves. And then you have to figure, okay, maybe I'll back off and take it a different radius out. And you start to experiment with, where am I getting reasonable looking data? So you have to worry about the reflection point. And then you have to worry about, you have a reactive place close to the antenna. Then you have where the fields try to get together, and finally you get far field. So there's near field, reactive, near field, far field. So you have, if you measure in the far field, that's good, because that's where the beam has formed, all the vectors come together, and it's nice and happy. The bad news is you run into the nasty thing called the real world. The FAA doesn't like for drones to go more than maybe 400 feet beyond the topic that you're worried about. And looking at this graph here, you may have to go 5,000 feet away, which means you have to have a waiver
to get into the far field.
To get into the far field to measure the antenna. And they're not always willing to give you that kind of a waiver. So you have the waiver with the FAA, you've got local law enforcement and zoning. They may not like you to be flying drones over people's houses. There's a safety factor. So when you do a helicopter measurement, it's obvious. Big, noisy bird, got to be up in the sky away from people. Drone is just smaller and annoying in a different way. But you still have to be worried about, you can't fly over people. FAA says no, unless you have their permission or you get a waiver. And you can't fly above certain installations. There's a lot of you can'ts, even if you're a commercial. In fact, it seems like if you're a commercial drone pilot, it's harder. You have to be, there are more restrictions. You have to be more responsible. So that's sort of the, I'm dumping all of it into a very fast conversation.
That's all right. Well, there's a lot to cover. You mentioned this, the individual element vectors, and that I had not heard it put that way. I think I understand far field, but this photo really shows what you're talking about the pattern forming out there in the far field, and that graph in the upper left-hand corner. Exactly. And then the graph in the lower right does show, the bounce that you have to either discern or plan for or see what's there, right?
Exactly. Yeah. Just like with an AM antenna where you have multi sticks up in the air to form the beam, and you might not get a pattern forming for 20 miles. The same thing with an FM or television. The different elements throw the stuff out there, but they don't combine until you get so many wavelengths or fractions of wavelength beyond. And for example, let's talk about oh, let's look at a cheat sheet here, like an ERI antenna, 24 elements. I need to measure that probably greater than 2,400 feet away to do it right, at least for the vertical pattern. I can go in and do the horizontal pattern a little bit closer in. So sometimes you trade off one type of accuracy for another to get, I'm looking at relative measurements perhaps. Is this thing, as it was shipped from the manufacturer, did something happen in transit? Did something happen in installation? This could tell me very quickly, is there a problem with the antenna? Did it get hurt in transit?
Yeah. Now you mentioned it.
Something that's been up there in the air for a while. I mean, I was chief engineer at a Channel 2, and we were using an old Channel 2 batwing antenna. And all of a sudden we started getting viewers on the east side of the signal calling in and complaining that they couldn't see us. And we took a look with a long lens. We took a look with a couple of pair of binoculars, couldn't figure it out. We finally had a tower guy go up the tower, and he told us that somebody had managed a lucky shot and put a bullet right through one of our elements on the east side of the antenna.
Oh,
no. And if in 1995 I'd had a drone to do that, I could have saved the tower climb. Because it would have been obvious that the antenna wasn't radiating on the one side anymore.
And again, with drone measurements, they're a tool. You can't use them in every location. You can't use them in every situation. Some, like any other tool, sometimes a VNA is not going to work. Sometimes a Simpson 260 isn't going to work. So you have to choose your battles and use them intelligently.
It's another tool in your toolbox.
Yes, just another one of the tools. And it may be applicable, and maybe it's the exact wrong idea. So each one is, again, you learn through experience. And we're in the early stages of using drones for this sort of purpose. We're all learning. I think there's three, and I could be wrong, I think there's three entities doing this now. It's ourselves, Six Arms out of Australia, who comes over to the U.S. quite a bit, LS Telecom out of Germany. They come to the U.S. quite a bit. So there's three entities doing it all the time. And but it's still new. We're still figuring out. And by the way, the guys in Australia just finished measuring a radar, which is kind of cool. You just put the drone up in the air, let the radar spin. You've got its horizontal pattern done. So that's kind of cool.
Drone doesn't have to move. The antenna does all the work.
That's right.
Well, if we could, have we thought about building towers that you could just spin in place? Well, they do that at test ranges, but not
exactly.
Not in the real world, I suppose.
Well, I do have
that's a lot of payload, Kurt.
I do have a story about a famous broadcaster who everybody would know the name if I said it out loud, who got an antenna modeled, put it on a tower section that was rotatable at the very top. And he would had the tower guys go up and rotate the tower top until he got what he wanted into his market, which wasn't necessarily what he was licensed to. And you know who I'm talking about. But he likes squirt guns. But anyway, that's another story.
Well, there's always the city of license, and then there's the city of financial interest, and they often are not the same city.
It can be true. And that's what you can tell. Again, we had demonstrated this a couple times to the folks at the FCC, let that be a warning. And they're interested in direction finding. And also, gee, is that antenna really what somebody said it is? So that Big Brother will eventually have a chance to say, gee, did they cheat? And some people, believe it or not, Kurt, do cheat.
Oh, yeah. Actually,
You've probably heard that.
I won't tell the story on the air, but I think I found a Class A station in Tennessee that doesn't line up with its license filing.
Stuff happens,
Yeah. And it sure is pointing at its city of financial interest. So
yeah.
So I wish we had so much more time, but I want to get to our final topic. I think it's our final one, and that is talking about infrared photography. And this is something that doesn't require the kind of education experience that you have and that your firm has, but maybe something that, hey, maybe I could strap an infrared camera onto my drone and look for trouble before it happens. What kind of advice do you have for looking for trouble on your tower that's of a heat nature?
That's kind of interesting. You can get IR cameras virtually anywhere. Your hardware store has them now. The FLIR FLIR is probably the gold standard, and that's the one you would want to get if you can afford it. They have a fixture that you can actually hook up to your cell phone and use it to scan things within your plant plus the tower. I like the idea of walking around with a FLIR inside somebody's physical plant because you can look at things that or heating. It's I found a bad feed from the power company. They had a bad connection to a pole pig, for example. It was glowing red hot to the IR lens, and you couldn't see it with the naked eye. Or you can see panels and connections to panels, electrical panels in your plant that are about to give up, but you wouldn't know. They show the heat very well. And you can walk along the transmission line, the horizontal run with this thing, and gee, that seems to be a hot spot. Usually it's at a flange, or it'll be at an elbow, any place where there's a change. You can see that. As far as going further up the tower, in the ancient days, we had rented from FLIR an IR camera with a nitrogen-cooled lens, and it was like $150,000 to buy. We just rented because that's big bucks. And we scanned a tower here in the Washington area and saw that their antenna was about to go up, and they eventually had to replace it because it was just a matter of days before it at 700 feet up decided to die. So wow. You can also take, I think our mechanical engineer here fixed a FLIR phone camera to a little DJI or something, and he was able, little Mavic, and he was able to fly it up a tower and look at things. Again, you have to program it to maybe take a picture every so many seconds as you fly, but you can use that as again, it's experimentation, but that's a very simple way to try to go up and see, is anything looking hot.
These are some pretty interesting pictures on the screen right now. Tell me what we're looking at, and I think the most interesting may be the bottom right picture, but you go in any order you like and tell us what we got here.
Well, the top center and the top right are actually from a dual lens camera that we have on the drone that you see in the top left. It's a FLIR camera that has a regular lens and an IR lens on it. And you can see that they're the same. It's the same picture, but the one on the right is the IR view, and you can actually follow the transmission line.
Yeah, across the roof of the building,
which is just a little bit hotter than anything else.
And if you normalize the view to just the line and get it calibrated, okay, this is line normal temperature where there's not a problem, then you scan along the line, see if there's something a little bit hotter, and it'll show up as a white spot or a bright yellow spot, as you can see from the elbow in the center lower, and also the left lower. You can see that whole line is hot from the heat, but right there is that one, and you see it's even bent where there's a bad connection there, almost up to the elbow. There's a bad bullet,
and it's very hot.
It was very, very hot. Wow. We told this wasn't even, we weren't paid for this thing. We were just scanning somebody else's system. We told the chief of that station, hey, you're about to have trouble. No, we're not. Okay. And it was about 30 days and he had trouble. So, if I give you free advice, take it,
So to answer your question, the picture on the lower right was the
let's see that one again. Yeah.
No, that was actually the lower right.
Switch.
Very lower right would be inside a tuning unit. And that connector to the end of a coil clip was loose. And the same for the contactor on the upper left of that. That contactor's finger stock were getting loose, and you couldn't tell by looking at it, but it was getting ready to cause a problem, some sign on. So it's, again, just walking around one of these things. You can get them cheaply enough. Our one that's mounted to the drone is about, what's $10,000?
It was $10,000 for the dual regular lens and IR lens.
But you don't need to go to that expense to do just some basic house cleaning.
Well, you just bought a handheld one, and how much did you pay for that?
The handheld one was maybe $300 from Newark, so I paid retail.
So that's a pretty cheap insurance policy.
And I call it, I think FLIR calls it predictive maintenance. If you walk around your plant and look for places where there's where there are problems, if there are hot spots, is there air conditioning leaking? You can tell if there's rodents, believe it or not, behind a wall. Hey, look at that. I see something behind the wall. It's a critter. It's amazing what you can find with those little things. You also, if you shine it on, you eliminate an airplane or your car, you can see if the brakes are getting hot and how hot is one hotter than the other. Hey, I need a brake job. I mean, it's amazing what you can use it for.
That's a great idea. I hadn't thought about the automobile aspect, but yeah, do I need a brake job? Are these getting hot? And you've given me a great house. You've given me a new line item on my engineering invoices. I've got percussive maintenance. Now I've got predictive maintenance.
There you go.
Yeah. There you go. You do that maybe once a year. Just walk around and look at the plant with this thing. And also, as I said, look at your house. Look at the roof as you're standing outside. Gee, that I'm seeing hot spots on the roof. That means lack of insulation. That's where the heat's escaping, for example.
Yeah.
So these are powerful tools. It's funny, though, we started playing with IR, I guess, 15 years ago or longer, and people aren't really comfortable paying us to come out and do it. The good news is you can buy one of these cameras cheaply enough or rent them and do it yourself. You don't need to pay expensive folks like us. You can do it yourself.
I talking to you a few weeks ago, I think in Dallas, you mentioned about taking IR readings in the dark or maybe just as dawn breaks, but before the sun has had time to heat everything up. And I hadn't thought of that. And of course, it makes sense. Tell me about what happens if you try to look at a tower or transmission line or elbows when the sun's been beating on them for a while.
Oh yeah, it's like trying to look through something that's in the fog. The tower's heating up, the transmission line's heating up with thermal loading, and it starts to mask the heat. I mean, the difference between the transmission line fault temperature and the sun beating down on it up at the altitude of the tower, you'd be surprised how close it can come. So you want to look at the tower when it's cooled down, preferably late at night or before dawn in the morning. That's the best time. If you're too lazy, well, then you hope for maybe the winter on a cloudy day, and you can get away with that. But yeah, the thing about using it, like any other tool, like we started to talk about, the IR camera can fool you. If you get it near RF, it might mistake RF for heat. It might mistake reflection of a light for heat, which is odd. Or it might a shiny spot on a connector, it might think that's heat. So you got to move the camera around to say, okay, is it really a hot spot or is it just a reflection or some kind of other artifact? One note I wanted to share with you is when you're using drones around towers, a lot of guys like to take these beauty shots. That's cool. But part of the communication control system of drones is about 5.8 gig. On some towers, there's 6 gig antennas. And we have a tower climber friend who was taking beauty shots, went right in front of a 6 gig antenna, and the drone lost its mind and went zoom into a tree, and boom, there went his investment. So think about where you're going with this thing. Are you getting too close to RF sources, particularly in a sweet spot frequency where you're going to wreck your drone? Our drone is about $85,000. It's RF hardened because when that falls, it really hurts. So we make it so we can fly it up into the main beam of an antenna. The average DJI, not so much. And again, nobody wants to fly in front of a 6 gig energized transmit antenna. It's going to drive your drone crazy. So it's all about learning.
Yeah. Good advice. Good advice indeed. Hey, we're just about out of time, but I want to mention one other thing that's incredibly useful for engineers and even just curiosity seekers about licenses and so forth. And that is this website, fccinfo.com. And my favorite feature is this downloadable KML file that shows you what's where on a Google Earth map. Would either or both of you talk to us about fccinfo.com?
Sure. fccinfo.com is a user-friendly search tool for most of the FCC databases. So now that the FM stations are all in LMS, it's a front end for LMS. It's a front end for CDBS because the AM stations are still in CDBS. It has a front end for a search tool for the ULS database for microwaves and 950 and 450 frequencies. It's also got the tower database, the ASR database in there as well. And so not only can you search by call letters, you can search by owner or location or facility ID or call sign of the microwave or just about any search tool you can imagine. But you can also search it on Google Earth if you've downloaded the KML plugin.
And a cool thing is you can see the coordinates that the FCC think you have and the FAA think you have.
And then see where your tower really is.
And sometimes it's wrong. And by the way, even though they sometimes will deny it, I've had FAA call me and say, well, I've got this Google Earth tool, this FCC info. Do you know about that? Yes, I know about that. And it shows a tower here. And these are the coordinates we're getting from that. And you're showing something else. Okay, well, this was a surveyor. You sure? So, that's the tool is powerful in where other people are using it. The other thing to know about is just for fun is when you're in the KML tool, go to like the Empire State Building or World Trade or the Hancock Center and turn on the microwave links. You can see, and by frequency, you can see all the ones that are hidden behind windows. And you see all these spines coming out there. Or you go to Sutro Tower, it looks like it's a porcupine, all the links. It's pretty cool.
I was just I was just in New York City, up somewhere, and looked at the side of a building, and sure enough, the number of the windows had little dishes behind the windows.
They do.
Yeah. Wow. This hour has flown by. I feel like, wait a minute, we can't be done yet, but we've been talking for nearly an hour. Gary and Cindy Cavell, is there anything else you'd like to pass along that we hadn't gotten a chance to say yet?
Well, just on the drone topic, I encourage everybody to try to go out and use drones for their own stations, for inspections, for just getting the lay of what's going on with their property. And with any of these new tools coming up, you can get a pocket VNA you build yourself. Experiment with it like the old ham radio operators did. Play with the toys, get comfortable using the new tools, and don't hesitate to call some of the more experienced engineers who've used it before you. And most of us will be glad to help you out. It's all part of what we do. Again, we all have to learn because the future keeps moving in front of us. Indeed.
Well, thank you so very much. The website is cavellmertz.com if you want to look up Gary or Cindy Hutton Cavell and see what they have to offer. But what they've offered to us this hour has been extremely valuable, and I certainly appreciate it very much. Gary, Cindy, thank you for joining us. I appreciate it here.
Our
Thanks
pleasure.
for having us.
Thank you.
All right. And that's our interview and our meeting. Let's turn it back over to Chris Scherer. Chris?
Okay, Kirk. And again, Gary and Cindy, thanks very much for joining us. Thanks for watching today's SBE Webxtra. This episode will be available on demand on the SBE YouTube channel. And by watching this webcast, you've just earned a half of an SBE recertification point when you recertify. We thank our sponsor, Wheatstone, for supporting the SBE Webxtra. Watch for the announcement of our next SBE Webxtra, the chapter of the web, next month, usually on the third Monday. On behalf of Kirk Harnack, I'm Chris Scherer, SBE Member Communications Director. Thanks for watching, and we'll see you next month.